That's correct. Okay. I told about kinematic alignment first and the three kinematic axes. Remember? So now, the next interest is the second axis, pair group. So reproduce the native direction and the height of pair group. Anyway, so it is not possible, not perfectly possible so far. So it requires kinematic specific component or patient specific component. Okay. So let's move on to talk about kinematic UKA. So kinematic UKA is a similar concept to reproduce the cylindrical axis and the medial pivot motion. But in fact, as I said before, so lateral side is normal. On the medial side can be reproduced the cylindrical axis because so the aim of UK is to reproduce the patient native articular surface. As a result, lateral side and the medial side cylindrical axis can be restored. But this is the fixed bearing component. This bearing component is the multi radius. Again, there is under controversial, the multi radius and the single radius, which is the better, which is the best. Nobody knows so far. Anyway, so concept is quite similar to the kinematic alignment UKA. So how to do the kinematic UKA? This is the Charles Riviere. He's one of aggressive user of kinematic alignment. So this is the president of PASS meeting, PASS Society, Personalized Alignment as a Practice Society. Okay. And he is also Oxford University. So his technique is the first, draw the line.
はい。膝をすくサイズについて、ウェブでこちらが見つかりました。ご確認ください。
Okay. So draw the flexion facet. So longitudinal axis of the femoral articular surface. So we can see some, how we can say, scratch or so some lines. So that indicates the orbit of the joint contact surface. So they draw the line along this line, so longitudinal axis of flexion facet. Then cut the tibia perpendicular to this flexion longitudinal axis of flexion facet. But this is freehand. Oh, yes. Here, insert the K-wire into the medial joint space that indicates the inclination of the medial tibial plateau, so-called posterior slope. They cut the bone parallel to this K-wire and perpendicular to flexion facet. Theoretically, it's very good procedure, but it is quite difficult too because we should cut tibia without instrument, freehand. So it's very difficult. Furthermore, to cut the perpendicular to the longitudinal axis of flexion facet is not always accurate because there is no device, only the visually identify the particular lines. So I think it is not for everyone, only for the skilled surgeon. So I devised the new technique. So key point is spoon. So in most patients, so medial joint line, medial tibial plateau and joint line are parallel to each other. Sometimes so medial condyle and lateral condyle can be proximal apex, or sometimes distal apex. So, or maybe in most cases, the slope, medial slope of medial tibial plateau represent the joint line. So simply insert the spoon like this and set the cutting block. Sorry, set the cutting block. But in most cases, these are not parallel to each other. Like this. So originally, this cutting block is set perpendicular to the tibia axis. Okay. So then incline the cutting block so that the spoon gauge and cutting block come to parallel to each other. Then, as a result, this cutting block can be parallel to the joint line. So like this. For this purpose, we use slidable piece like this. As a result, this placement cutting block can be parallel to the joint line. Okay, I'll give you this presentation later. But in some case, so as I said, medial tibial plateau is not parallel to the joint line. In this case, I devise double spoon. Insert medial side and lateral side and connect them. And this represents true kinematics joint line in all cases. But this curve is very difficult because sometimes this is impede to the patellar tendon. So I now redesigning this curve and shape. Anyway, in the near future, I can use this one in all cases. And truly, kinematic alignment to parallel to the joint line. So using the double spoon. Okay, oh, this is the game. My interest is the how degree is the best for the media slope of the kinematic Oxford need. So I measured the component Veras angle. This the angle between the perpendicular axis of tibia axis and the component line. And another one is angle between joint line and the component line. So I defined this in JCDA, a joint line component divergence angle. So I think both are important, very important. So ideally, this is my opinion. Ideally, that this component should replace the parallel to the joint line, like TKA. What is the difference? So as I said, UKA is already kinematic alignment because both medial and lateral joint line, it should be same as the normal joint. But the difference is inclination of the component. I think the component should be all should be parallel to the joint line. Because the one reason is road distribution. Or maybe the displacement placement is not parallel to the joint line. I think so uneven, imbalanced joint distribution can occur. So all considered to the media side or lateral side can cause some trouble. So because the preoperative joint, so maybe even force can be affected on the medial tibial plateau and lateral tibial plateau. So I think it's the best to reproduce this road distribution situation. Anyway, so I show several times. So we've got two angles of the components. One is against the tibial axis, another is against the joint line. Well, this is a mechanical, so standard technique of Oxford is tibial component is virtually perpendicular to the tibial axis. But even in a mechanical Oxford, the tibial component, it tends to be placed at slightly varus, like that. Maybe due to the proximal tibial varus. So proximal part can move slightly medially. As a result, bone cut can be slightly varus. And sorry. So all component is placed in valgus against joint line. But in kinematic concept, of course, the component placed in valgus in terms of tibial axis. But virtually parallel to joint line. I think this is better because some trouble case such as fracture is concentrate to the minus GLCS. So if the component is placed valgus against joint line, can cause fracture. But if it is important, so fracture can occur if the component even if the component is placed in valgus. So I think so the set the parallel to the joint line is very important to prevent the fracture. The valgus side that is interesting. So it can occur both negative. So valgus, both tibial axis and joint line. So my solution, my opinion is never set in valgus. But sometimes so valgus alignment is a little bit too steep, but there's no complication. So I think valgus placement is safe, but never in valgus, both against tibial axis and joint line. So now I try to set as parallel as possible to the joint line. But unfortunately, my tool have some limitation of side slide. So up to 2 millimeter, that is counted for around 4.6 degrees in valgus. That can be a restriction. Even using this one, the tibial component alignment, sometimes 10 degrees or 8 degrees and 9 degrees. But nothing happened. Completely nothing happened. Patients are very happy. ちょうど終わりました。というところで。
このジョイントラウンで
うん。
観測、中点じゃない。
中点。あ、これごめん、間違ってんの、
あ
これ。間違ってんね。これ、それも前になんか指摘されて。うん。OK。That's all. Okay.